thing I can do there. A couple of things. Yeah, you could do into parentheses. I like it. So what do you get there? -2 plus -3, I owe $5 total. I like it. And what's up here? What's this?
9.
I like it. -3 times -3 is 9. And real quick, technically, what is this? This is not 9.
So minus 3 squared.
Yeah, 3 squared is 9, and there is a -1. So this would be -9. And that follows order of operations, because order of operations says exponents before multiply. Yes?
Where does the negative go if it's in the parentheses?
Okay, so if it's in the parentheses, what do I have 2 of?
Negative.
I have 2 -3s. And what's negative times negative?
Oh, okay, yeah, sorry.
And real quick, why is negative times negative positive? You ready? All right. This is kind of cool. Anybody ever heard of something called, I'm not going to talk about this today, but what I'm going to talk about today is an easy setup for weirder stuff later. There's numbers called complex numbers.
Yeah.
And part of it is unfortunately called imaginary numbers.
Yeah.
And negative numbers. Is everybody cool with negatives existing?
Yeah.
No. I don't think they should
All
exist.
right, I'm sorry. Let me say this again.
No negative rights.
Does everybody understand that negatives can exist?
Yes.
We don't like that they exist like in my bank statement,
Yeah.
right? You're overcharged, so we're going to charge you money. I'm like, I don't have any money. You're going to charge me money? Anyway, sorry. You overdrafted. We're going to charge you $25. I love those days. So real quick, how long is it going to do? Shit. Oh yeah. Watch this, guys. So here I am at 1. When I multiply by negative, do you see how I turn around? 180 degrees. Right, we never really looked at it like this before, but this is going to help us out a ton when we get to those funky-ass imaginary numbers. Imaginary numbers are just turning part of the way. Right. So when I multiply by a negative, whatever number I multiply by a negative, it flips 180 degrees, doesn't it? And so if I multiply by another negative, it's going to do that again and come back to where it was. So 2 negatives is like saying to somebody, all right, turn around. All right, turn around. Okay. Right? And so that's why 2 negatives cancel when you are multiplying. Because when you multiply by negative, it means turn around. So 2 turnarounds, you're back to where you were. Okay.
So if you cubed it, 3 exponent, then you would turn back around to 30.
Yes, and that's why, I got too much stuff up here. That's why if I have a negative number to an odd power, so what's -1 to the 111th power? That's easy now.
Negative 111.
No. It's either 1 or -1.
Wait, what?
You ready?
Negative.
Stay with me. If I go an odd number of turns, if I turn an odd number of times, I end up back here, don't I?
Yeah.
So that's exactly what this is saying. So this is -1. What's -1 to the 208th? Because it's an even number of turns, so I go make a complete circle, I'll come back to 1. You guys with me? All right, I like it. That doesn't change too much from the way I used to teach it, but this picture, when you do talk about complex numbers, imaginary numbers are just stopping here. But that's too much to get into today. It's a little freaky. Yes?
Yeah, the example of the flipping the number line, that helps a ton. Like that's great.
That's why, so it's multiplying by a negative, that means turn around. That's why it only cancels when you multiply. When you add negatives, you get more negative. Everybody knows, I dig 4 feet down, it's -4. Dig 4 more feet, I'm not on the ground again. Oh, I'll be there. No, it's not going to cancel. I don't know if you guys are, if I, -4 minus 4 is now I'm 8 down in a hole. Oh, shit, all right. Yes.
So instead of a -1 times 111, how about a -1 times 0?
No, be careful. This is -1 to the 111. Okay, good.
So
Just make sure.
-1 to the 0.
All right. I was getting ahead of us. What's anything to the 0 power?
0.
Careful.
Oh,
1. It's 1. It's a little ahead of us. I don't want to go there yet. Huh?
What happened to the negative?
Oh, well, this means, now watch. This is awesome. This kicks so much ass. You ready? You ready? Where am I assuming I start all the time? I start at 1. Negative 1 to the first power means do one turn. What does this mean? Don't do any turns. So of course I'm still at 1. How many negative 1s do I apply to 1? None. So where am I? I'm at 1. That's another way to look at it, which is neat. I've never really thought about it that way, to be honest, until just now. There's a whole other way to prove that 0 power makes things 1, and we'll do that when we get there. Okay. All right. I love so many guys. I'm really, really sorry. I'm going to try to make a distinction between, I think I've done a decent job of that, of something you have to worry about later this semester and something you have to worry about now. Right? Okay, like the imaginary numbers, you don't have to worry about that shit at all. Right? Not yet. All right, let's get back to this thing. We're almost done with this. What's the next thing in this?
Multiply.
Good. Now, you could either do this. I'll do it the way I think is better, and then I'll do it a different way. Show you they come out the same way. So this says negative 5 times negative 5. What's that?
25.
Positive 25. And what's 9 plus 25?
34.
34. Now, in case you want to see this, you could also look at it this way. What is 5 times negative 5?
Negative 5.
And what's in front of that? 9 minus. You see that? What's in minus and negative? Positive. So of course you end up at the same place. So math has to be self-consistent. No matter which way you choose to look at it, as long as you apply the rules correctly, it must come out to be the same answer. At this level, just to let you know that if you get further in math, you get to a point where there's not always one right answer. Because that's what people love and hate about math. It's so cut and dry. Not always. You got fuzzy math, you got cake. You guys watch Jurassic Park?
Yes.
Good old Jeff Goldblum doing his whole drop of water. He's of course flirting with a girl, but mostly it's like what I'm saying. Drop of water, if you put it in exactly the same place, who knows which way it's going to go? Chaos theory, right? So if you start with the same initial conditions, do you get the same answer? No, it's chaotic. There's too many things. Yes.
Don't like math majors have to, like a PhD have to like create their own like formula for an answer usually, their own mathematical solution for it?
It happens, of course.
Yeah.
Because what math really is a series of ideas. You guys learn like at least 2 equations of a line, for example, right? You guys remember an equation of a line?
Y equals mx plus b.
Dude. And there's another
I
one.
remember.
Okay, sweet. This was your moment. I love it. But there's one more, stay with me. There's one more way to write it that you normally learn. Y minus y1 equals m times x minus x1.
Yeah.
Those are equivalent. And then there are more ways than that. But they all deal with one idea. So in math, the real math is get the idea and you can handle any freaking way they choose to represent that idea. I know right now you're like, what's that mean? But I mean, I just want to start you to realize that math isn't all about learning like pieces and parts and this is a formula, you always use a formula. No, it's what's the idea that went behind this. The more you understand that, the more you know when to use a formula, the more you can handle when things get freaky. Okay, enough of that. So we'll hit that throughout. I'll say that same thing throughout the semester. It's the idea that matters. So what's the idea on this one?
Simplify.
This particular problem is like a pure order operations problem. Right? Order operations never goes away. It's like the grammar of math. But this is like just a straight up order operation. So what am I going to do first here?
4 minus 2.
Yeah.
2 to the 6.
Now the biggest mistake I see is somebody puts a 6 here. That is a mistake. And I really want you to understand why. In that whole problem, what's the only number being divided? 2. So it's not fair to this problem to suddenly say, no, it's divided by 6 now. I really want you to understand that. It's not divided by 6. It's divided by 2. The 2 would be on the bottom, wouldn't it? Over 2 times 3. The 3 is on top. Do you guys see that?
Yeah.
That's why you don't, whoa. That's why you don't necessarily multiply before divide. You just do it as it comes. That way you make sure that the things on the bottom don't interact with the things on the top like that. Okay, maybe. Unfortunately, there are teachers that actually teach that multiplication is before division. And they need to stop. They are not good math people. Okay, so we know better. Does that make sense though? The 2 is the only thing that would be in the bottom. How would the 3 go with it to make it 6 if it's not down in the bottom with it? It isn't. It's times 3. If you look at it like that, you're not going to make that mistake much. Every now and again. We're human. We're going to do that shit. Oh, what's the last thing I'm going to do in this whole problem? Good. So this is just going to come for the ride. What's next over here?
4.
Good. 2 squared. Square. 2 squared. What's the next thing?
4 divided by
Good. This whole chunk. Holy crap. It's like my 8th puberty. This whole chunk is multiplication division. You do it as it comes. So you get 4 divided by 2.
2.
2. 6. Good. So 3 plus 6. Now I can finally do that addition because it's the last thing left. Chickens, yes. What about part B? What's the idea there? Like terms.
Wait, so what do you divide after?
Where are we at?
I just was at the divide part. The first one.
Yeah. Oh.
What do you divide that by?
So right here, what's the only thing that I'm dividing by? 2.
2.
So 4 divided by 2 is 2. The division's gone because it's been done. Does that make sense?
Yeah.
I like it. So here, what's like terms?
X.
You have 5x
-2.
minus 2x.
3x.
I got 3x's. I got negative 3y's and 10y's. I got 7y's. Done. That can't become 10xy or something. I don't have any xy's. Yes?
So, how does the 5x and the 2x interact if they're both being interacted with first by
Oh, I see.
previous line?
I'm with you. Because we have commutativity. If you're going to do, I know nobody does this anymore, but if you're going to do like a checkbook or something, wouldn't you take all the positives and then add up all the negatives and then subtract those? So you don't necessarily do it in order as they come. Let me say this. I can add any order I want to. But then your next really good question would be, there's some subtraction in there, math boy. You better. Hopefully you wouldn't say that.
What'd you call me?
No, I call myself now.
Okay.
I gotta pay attention. That was you talking to me.
Okay.
Yes.
The X, the Y's, where would you get the number for those letters?
I don't know what the numbers are. That's the point. So very often we're going to work with problems that have formulas that if I knew what the letters were, I could put it in. But there's a situation where I don't know what the variables, I don't know what X is. I don't know what Y. They could be anything. But I do know, since I have 5 X's and I'm subtracting 2 X's, I know I got 3 of those things. I don't know what the shit they are, right? Do you understand? So if I had 5 boxes with blue tarps on them, and I took 2 of them away, what's in the box? I don't know. But I know I have 3 of them now, right? So there's 5 things I don't know. I took 2 of them away, so I got 3 of those things I don't know. What about the other stuff I don't know? I had 10 of them, I took 3 of them away, now I got 7 of these things, these other things that I don't know. You see what I'm saying? Now, your question is, all right, help me out. What's the difference between 2 plus 7 and 7 plus 2?
Nothing.
Nothing, 11.
Well, just where they are.
And the result is the same.
Yeah.
So they both represent the same amount of stuff, right? Now watch. What's the difference between 7 minus 2 and negative 2 plus 7?
Oh. Shit.
All right, cool.
Okay.
I know how much. You guys with me?
Yeah.
Because this is plus negative 2, so I can add things any order I want to. So that's why we're allowed, even if they're not standing next to each other, I can move it over. I don't actually have to physically move it over. I could just do it in my head. Yes?
So, these are non-negatives just because the smaller number happened to be negative, right? Like you
Good,
don't-
I love it. So if it would have been 3y minus 10y, that would have been negative 7y.
Okay.
All day.
Okay.
I like
Sorry,
it.
dumb question.
No, not a dumb question, yes.
So then it basically just becomes negative 5x, so negative 2x plus negative 5x, which brings us to...
There's no negative 5x. Careful. There's a 5x.
Oh, right. So
And then negative 2x.
plus 5x, which
Beautiful.
brings 3x.
Beautiful.
And then that minus sign stays there, so it's a negative 3y plus 10y.
Beautiful.
Which brings us to 7y.
7y. I like it.
Okay. And then it doesn't matter if it's negative 7y plus 3x because it's the same thing either way. Or negative 7y plus, sorry, not negative.
If
7y
you put
plus
7y
3x
plus 3x, you would be
7y.
fine
It's
still.
the same thing.
It's semi understood that we normally try to get them in alphabetical order, believe it or not, but it doesn't matter.
Oh.
So 7y plus 3x, I would still take it. Just sometimes.
Okay.
Yeah. The bigger convention is something you guys might be related, is like descending order, like you would say x squared plus x plus 2. Instead of x plus, I can't remember what I said, x plus x squared plus 2. You would put them in descending order of powers. That's the one that's really like, you gotta do this. Alphabetics is sort of like, all right, what about this one? 3. Yeah, you can divide both by
15.
Yeah, you actually can. I like it. So you can either do this in steps. Real quick, here's something. How far apart are 15 and 45? 30. So any multiple of 30 could be something that goes into both. Because how far apart are the multiples of 3? They're 3 apart, right? Or what about 3 and 9? They are 6 apart. I don't know if you guys are seeing what I'm saying. So to get a guess, when you have something that's growing, this is not that bad. But if you're trying to get a guess as to what to divide into something, see how far apart they are. And factors of that number might go into both. And in this case, 15 goes into both. Now watch this. And if you don't see that, you can see the 5 for sure, right? So you can always do this in steps if you need to. Divide by 5, divide by 5. 15 divided by 5 is 3. Okay. I love it. 45 divided by 5 is 9. And then you can see the last step, of course. Right? Divide by 3, divide by 3. So notice I divided by 5 and then I divided by 3, so I could have divided by 15 and gotten there. So it doesn't matter. Who gives a shit if you happen to see the 15? As long as you get to the 1/3, you're good. Just don't stop too early. Make sure real quick, did I do enough? All right. I like it. Yes. Oh yeah, now we're getting good. Here's the one where I get like 1 over -1 or something. Now listen to me. What is 3x minus 2y?
It's that.
It's that. I love it. You would circle that shit and say, give me another one, John. So doesn't that say exactly what he just said? 3x, 3/4, minus 2/5. 3 somethings minus 2 something else's. So how the shit would you be able to put those together? They're not like terms. You've got to make them like terms, which means like denominators. But some people just don't see why that's necessary, but hopefully what I just said makes sense. It's all about like, I can't put them together. I could put 3/4 minus 1/4, because now I know how many fourths I've got. This is 3/4 minus 2/5. How many whats do I got? I don't know shit. They're not like terms. Common denominator. So, here the common denominator is easy because they both need each other, right? Aww. This one needs the 5. This one needs the 4. So you get 15 20ths minus 6. Yeah. 8 20ths. 7 20ths. I like it. Yes.
Country you did different, right? This.
Yeah. Same thing. I like it. You just combine them and got the LCD at the same time, which is beautiful.
It's good.
I kind of separate and then combine. Beautiful. Most math differences are just choosing to do something before something else in a different order, and sometimes that's legal and sometimes that isn't. But you're fine. I put the next one because this happens all the time. I always get somebody telling me the answer is 36. There's no way in hell that's 36,
18.
right? Because I'm not squaring. How many 3's do I have in that problem? How many 2's do I have? So how can you make 2 6's from 1 2 and 2 3's? You guys see the right way to look at that? And of course, the ultimate right way is freaking exponents before multiply, right? That's the straight rule. I like it. So this is 2 times 9, which is? I like it. This kind of creeps in when I see somebody, when I have 2x squared and they tell me that's 4x or something. I'm like, what the shit? What's being squared here is x. It can't suddenly just drift over. Oh. All right, here we go. This is from earlier. So I promised I would show you why 0 power is what it is. I'm going to do it here. Now we know it's always 1. Anything to the 0 power is 1. What's 1 minus 3?
-2.
-2. Let's talk real quick about why a 0 power makes something 1. I think we're going to do, I think I told you last time we would do our filter tomorrow, right? So we're still going to do that. I was considering today, but I want to keep going with this. No way. So I want to show you, let's do this up on the board. I want to show you why 0 power does what it does.
So when it becomes 0, like, which number becomes, the power becomes 0?
I'm sorry?
Like, when it comes like this
Oh,
one,
shit, I
like
see what's going on.
0.
All right.
When it becomes like 0. This
Oh, it becomes 1. It never becomes 0.
one. Never?
Never. All right, you ready? Watch up here. You guys remember what to do? Let me see if you guys are ready for this. Let's make it this. Yeah, what? Real quick, stay with me. Stay with me. How many x's on top? 5. How many x's on the bottom?
3.
How many x's cancel?
3.
How many x's left? 2. Okay. So why do all that work? When really what you really are fundamentally doing is killing x's. So how many x's will you kill? 3 of them. There were 5, so now you got 2.
Even if the x's were numbers, you could still do that, like cross.
Totally. So what is 4 to the 7th divided by 4 to the 3rd?
No, I mean like the denominator and numerator, like, or is that the right terminology?
Denominator,
Yeah,
numerator?
like what if it was like flipped, like they weren't both 4s? Like what if they were different numbers? Could you easily just cross
Oh,
them
the reason this works is because they're the same base. Good point.
out?
So this was y, or if this was 5,
So
none
what
of the shit
happens,
works.
like with that?
Yeah. Huh?
Like how would I solve like something like
Then
that?
you'd have to just do the world shit. Right? Okay.
Wait, would I solve the exponents first and then go
You
through
can't.
the?
No. The only time you're allowed to subtract. Why does subtraction work as a shortcut? Because the bases are the same, so they do cancel. Do you see where the subtraction comes in? There's an idea of subtraction. I'm killing x's, so I'm losing x's. And I know when you look at that, what's the operations? Multiplication and division. So where's this idea of subtraction coming? Because I'm losing x's. How many x's will I lose? 3. I had 5. 5 minus 3 is 2. I got 2 left. So this feels wrong, because you're like exponents are about multiplication. Why would I subtract them when because you're losing some of them. Is this all right? You guys all right? So sort of like if I had x to the 5th times x cubed. Yeah, because I got 5 x's in a row. Link another 3 x's in a row. So now I've got a total of 8 x's in a row. So every property of exponents comes from this basic definition of math people being lazy. I don't want to write 5 x's. I'm just going to write x with a 5 on it. And everybody, I'm going to tell everybody, that means 5 x's. Okay. Right? And real quick, what does this mean, really? Anybody know what that is? Don't say 5 times x. So somebody use 5x is doing what? Adding. So when this poor dude came along and he's like, God damn it, this guy already took that shit. Let me put B5 here. That is not very far off from the true history, right? So the fact that exponents mean what they do is just because some dude decided to and nobody thought it was a bad idea. Or the one guy that did think it was bad, they poisoned him. Because man, things were weird back. Yes.
And so if it was, so 5x equals x plus x plus x plus x. So if it was x5, that'd still be the same because addition can
No,
be
x to the fifth. Oh, I see what you mean. If I had x5, like
Yeah.
x times 5, these means the same thing, yes.
Yeah.
But you never see that, so that there's no confusion.
Can you do that?
You can.
Weird though.
Weird.
Okay.
Because then it looks a little bit like you just dropped the 5 too much.
It's like
You
putting
mean
shoes
this?
on the wrong
Yeah,
feet.
yeah,
Like
yeah.
you can walk, but it's bad.
Yes.
Okay.
Yes. I'm not an orthopedic doctor, but I'd say that's bad. Okay, so stay with me. So with that in mind, just a real quick, what's x to the 10th divided by x squared?
X to the 8th.
All right. So you get the idea, and so you see why the shortcut works. A lot of what we do in mathematics is actually a shortcut, which is if you're taught that way, it will make no sense then. So if nobody takes the time to tell you this, then you're like, I'm just going to memorize this shit, and math don't make no damn sense. But you're like, oh shit, that's why it's subtraction, it makes sense. It's just a shortcut. Okay, maybe. So, now watch this. Here's where we get cool. What's x to the 4th divided by x to the 4th? You can know. Yeah, 1. I like it. I'm sorry. Give me a second. I didn't want you to go there yet. But yes, something divided by itself is 1. But what is it based on the rule we've been using?
X to the 0.
X to the 0 equals 1. What's something divided by itself? 1. What's x to the 4th divided by x to the 4th? X to the 0. And another thing. So watch this. X is x. Wow. X to the 1st, right? What's x times x? X to the 2nd. Now let me go the other way. What's in front of this? Understood. 1. So if I keep multiplying by x to go this way, that must mean I divide by an x to go this way. So if I divide this by an x, I'm left with 1. If I divide this by an x, I'm left with x to the 2nd. No x's. If I have no x's, that must mean I just have the understood 1 left. That's why anything to the 0 power is 1. There's 2 different proofs of that one thing. Right? Some of you guys are like, that's cool, and some of you guys are like, I didn't need to know that. Yes, you did. Okay. All right. That's that. Okay. Just a little side note. Yes?
How do you know what to divide over the times?
Well, this is obviously, let me think. In what sense? This is obviously division, right?
Yes.
Okay. And then this example, where'd it go? I think I took it away. Yeah. This example would be multiplication, right?
Right.
So this is where I get a lot of people tell me the answer, this is x to the 14th. And then I say something I love to say. There is no 2 here. And then I got students that are like, he's off his meds. Do you guys see what I mean? There's no 2 in this problem at all. And you're like, huh? But what's that mean? There are 2. So there's no number 2. There's 2 x's that I captured like this. And then there's another 7 x's. So if you say 2 times 7 for 14, I'm like, there's not even a 2 or a 7 in there. Do you guys see what I mean by that? I'm freaking somebody out. I know I am. Because you're like, but that 2 means 2 x's. So it really is x times x. I just shorthanded it. There is no number 2. There is no number 7. So where the shit would 14 come from? There are 2 x's, 7 more x's on top of that, so of course there's 9. That's why you add when you have like basis multiply. Yes, and then you,
So essentially what you're saying is when you're multiplying, you would add, and when you're dividing, you subtract.
yes, beautiful. I love it. I just want to make sure you understand why that's true. In fact, one year I was teaching this girl was on the cheerleading and she did this thing about multiply is add. And then she had other shit I forgot. This is all I remember. When you multiply, you add exponents. So, and then she had another add. Okay, let's go back to the,
Wait, me.
what's up? Yeah.
Yeah, is there ever a time that you do multiply exponents or divide exponents?
Of course. So x squared cubed.
Oh, that sucks.
What's, no. What's, yes, why? What's something cubed? You write that thing 3 times. What's x squared, x squared, x squared? X6, 2, 4, 6. If I have 3 groups of 2 things, I got 6 things. 3 groups of 2 people. How many people? 6. So this says 3 groups of 2 x's, I got 6 freaking x's. So you multiply when you raise something with a power to a power.
Okay, follow up to this. Know the parentheses and then to the power of 4th. What do you do
You
then?
multiply all that shit together, you get 24.
Like 3 times 4 or 3 times 2?
So if you have this, yeah?
Oh, so so it's the innermost, because PEMDAS, it's the innermost parentheses first or the outermost parentheses first?
Does it matter what order you multiply?
No.
There you go. Since the fundamental idea is multiplication, I don't care how you multiply those numbers, it's going to be 24. Right? 3 groups of 2 is 6. 4 groups of 6 is 24. You just do 2 times 3 times 4. And then you can keep going. Right? All right, I'm sorry. Some of this stuff is going to come later this semester, so if you're not quite getting all the exponents, I just wanted to try to show you where the 0 means what it means. Later we'll get deeper into the exponent properties again. Okay? There's still a few more that we got to talk about, like negative powers. Not today. Okay? And then fractional powers. Definitely not today. Oh wait, let's get back up here. Probably running out of time. 4-day-a-week class is good and bad. There's never enough time in any individual class. All right. Oh, we only got a couple left to do. Oh boy. So just to save somebody, in case anybody wrote this, 2 things. That doesn't make sense. And that's not how to say it in English. How do you say this phrase in English, even though it's wrong?
5 is less than 3.
5 is less than 3, which is not true, right? So that's not what this says. This says 5 less than 3. Sorry? So the big mistake people make here is they say it's 5 minus 3. That's wrong. That's backwards. If you had 10 turtles for some reason, and I have 2 less than you, 2 less turtles. Is it 2 minus 10? I got negative 8. I got little black hole turtles. Negative turtle. Not sure what that would mean. I'm like, I don't know why I'm holding them like this. Because they're freaky. So 2 less. This is English's fault. I'm not saying English sucks. I'm just saying this. In this case, it is the English that makes the math harder. 5 less than 3 is 3 minus 5. That's the only one of these translation problems that you have to write this way. And when we get into word problems, which we will, this is where people are going to have negative side lengths of sheds that they're building or something. I want you to build a shed for me. Well, this side's got to be negative 7 feet, Jeff. What? I don't think they sell that at Home Depot. I need negative 7 feet worth of what?